Hi everyone, so today we'll be looking at writing ionic equation. So let's take a look at some examples. So the first example is write the ionic equation for the reaction between lead nitrate solution and sodium chloride solution to produce insoluble lead chloride and sodium nitrate solution. So the first thing we're going to do is write the balanced chemical equation. If you do not know how to write balanced chemical equation, there is a video that shows how to write or how to balance chemical equations right before this, okay? So you can go ahead and see that before coming here. So we have lead nitrate plus sodium chloride, okay? As you can see, there's already a 2 in front of the sodium chloride because I have already begun to balance it, okay? So many a times you will get questions that only says that says only lead nitrate solution and sodium chloride, and you won't know what is the products, okay? In the cases that you receive questions like those, there's a simple way for you to find the products. Here I have a little formula that says AX plus BY will give you AY plus BX, where A will be lead, X will be nitrate, B will be sodium, and Y will be chlorine, okay? So then our products would be AY, which would be lead and chlorine, which would be lead chloride, and B, which would be nitrate, and sodium, which would be sodium nitrate, okay? And our equation is already balanced, as you can see. The second step is to rewrite the equation showing ions present on solutions as individual ions, which means we're going to take lead, find its respective ion, nitrate, find its ion, sodium, and find its ion, and so forth, okay? So we want to know what is the ion of lead. We will find lead. Lead is here. So the respective ion for lead is 2+. Okay, so we're going to write lead as 2+. Now we have to find for nitrate. We go back, find nitrate. Nitrate is here, and it is minus. Okay, so we'll then have 2NO3 minus plus sodium. Sodium would be +1. So we have 2Na plus. Chlorine be minus. So we have 2Cl minus. And then we have lead chloride. Why lead chloride is not stripped off into its respective ion is because lead chloride is a solid. Anything that is solid or liquid does not break down in their respective ions, okay? And now we have this. We have the sodium and the nitrate again, okay? So now the next step as we finish that is to delete uncharged ions, which means ions that are the same on the product side and the reactant side. So we're going to rewrite what we had just done and now eliminate the ones that are the same. So we have the nitrate and the nitrate, then we have the sodium and the sodium. And there we have it. Now we just rewrite the ionic equation where we have lead plus chlorine will give you lead chloride. And that's it. That's all you do. Okay? So now let's take a look at another example. Now this one just says sodium carbonate and iron 2 chloride. You see, it's the same thing that I was saying previously. So the first step we're gonna balance the chemical equations. We have sodium carbonate plus iron chloride. We do A with Y and B with X, okay? That will give us iron 2 carbonate and sodium chloride. Now step 2 is to find their ions, okay? We have sodium, that's a +1. Then we have carbonate. Carbonate is 2 minus. So we have plus carbonate 2 minus plus iron, which would be, as you can see, 2 plus, and chlorine. Chlorine is minus. So we have 2Cl minus. Then we have iron 2 carbonate and sodium with chlorine. Remember, iron 2 carbonate is a solid, so that does not break away. The next step is to eliminate all the charges that are the same. So we'll rewrite what we have done and now eliminate them. We have the sodium and the sodium, the chlorine and the chlorine, and that's it. So now we write the Ionic equation, which is carbonate plus iron will give you iron 2 carbonate. Awesome. So now let's take a look at a different example. We have example 3, which says magnesium hydroxide and hydrochloric acid. As the same, we follow the same process. Magnesium hydroxide plus hydrochloric acid. And we just follow the same formula. A, X, B, Y. Remember, this is A, this is X, this is B, and this is Y. So magnesium with chlorine. So we have magnesium chloride. And hydroxide with hydrogen. So we have water. Okay? So the next step is to find the respective ions. Well, as I already put there, magnesium is 2 plus, as we see it here on the ionic state of elements. Magnesium is 2 plus. Then we have hydroxide, which is minus. Then we have hydrogen, which is +1. So we have hydrogen plus, and then now chlorine is minus, as we had already done an example previous to that, okay? Then we have magnesium 2 plus, chlorine minus, plus water, because water is a liquid. So that does not break down into any respective ion. The next step is to eliminate all of the ions that are the same. So let's rewrite. We're going to eliminate magnesium with magnesium, chlorine with chlorine. And the final step is to just write what is left, which will be hydroxide plus hydrogen will give you water. And that is your ionic equation. Okay? So let's take a look at another example. Here it says potassium chromate and calcium chloride. Again, we're gonna put potassium chromate, calcium chloride, and that will give you that will give you potassium chloride and calcium chromate. Okay? We follow the same example here with this little formula. So next step is to find the respective ion. We go and find potassium. Potassium is 1 plus, so we put potassium plus. Chromate is 2 minus, so then we have plus chromate 2 minus, and then calcium is 2 plus, so we have calcium 2 plus, and then chlorine, as was done previously, is minus. Okay, chlorine 1 minus. And because we have already found these one, well, we just fill in the rest for the remaining. Okay? So the next step is now to eliminate all the charges that are the same. So we will rewrite what we have. And there we go. We'll eliminate potassium with potassium, chromate with chromate, calcium with calcium, and chlorine with chlorine. As you can see here, all of the ions are eliminated, which means that they are spectator ions. Okay, there is no ionic equation, which is possible. So now let's take a look at another example. This example is ammonium phosphate and zinc nitrate. We have ammonium and zinc. Remember to always balance your chemical equation. All of my equations are already balanced because I had already done a video previously that shows how to balance chemical equations, okay? And their products is ammonium nitrate and zinc phosphate. So as we have done before, we will find now the respective ions. Okay? So let's find their ions. Ammonia is plus, so we have ammonia plus, and then phosphate is 3 minus. Okay, phosphate is 3 minus. Plus zinc. Zinc is 2 plus. And nitrate is minus. Okay, so we'll just rewrite it again. Remember, zinc phosphate is a solid, so that does not break into any ions. All right? So now we're going to eliminate all the ions that are the same. So we're going to rewrite and now eliminate them. We have ammonia with ammonia, nitrate, and nitrate. And that's it. Now we have phosphate plus zinc will give you zinc phosphate. And there you have it. So that is all the example I have for today. And as I always do, I will give examples at the end of my video for you to solve. All right? So here you have it. So your exercise is sodium carbonate and hydrochloric acid produces sodium chloride, carbon dioxide, and water, and lithium hydroxide and barium chloride. So I recommend you to write them down, pause the video, write them down, and I'm gonna go back to show you guys the table that has all the ions for each element, okay? And after that, I will come back and give you the response. Right? So this is the table. Don't pay attention to the triangles that are in different colors. Do not pay attention to that. That was just from the previous examples, okay? So take a look, pause the video, and look at it. And when you're finished, well, you'll go back and check the response, okay? So here are the response. If you have that, awesome, you understood how to write ionic equation. If you did not have that, well, rewatch the video again and practice more, all right? For today, this is all, and I see you again next time.